For this video, we want to use an appropriate substitution to evaluate each of these two integrals here. And we're going to look at a U-substitution. Now, sometimes these are pretty obvious. Sometimes you have to do a little bit more. Notice if I take the derivative of the denominator, I get 2x plus 6. And that's a multiple of this. So if I let the u equal to what we have in the denominator, we'll get something that'll give me a multiple of what I have in the numerator, which is what we need for this to work. So if I take the derivative here, du, on the right side, derivative will be 2x plus 3. This will be a dx here. And I was looking ahead here, it's 2x plus 6. 2x plus 6 dx, and then notice if I take out a factor of 3, I should say 2. I get 2 times x plus 3 dx. And notice that's sitting right here in the numerator. So that means that x plus 3 times dx, I divide through by 2 here, these will divide out. So I know that x plus 3 dx can be replaced by du over 2. So in my next step, x dx, replace it by du over 2. I'll put the 1/2 out in front. The denominator is x squared plus 6x plus 7, and that's my u. So I get u here is equal to 1/2. And the du over u, of course, is your natural log of absolute u. But absolute u, or u rather, is equal to x squared plus 6x plus 7. And that's your constant, and plus the constant of integration. So we simplify this to making the substitution for x plus 3 dx and the x squared plus 6x plus 7. That's your u. So the x plus 3 dx is replaced by du over 2. And then the integral of du over u is given by 1/2 natural log of the u, which is x squared plus 6x plus 7, so plus the constant of integration. So that's the answer, the value of the integral for problem 1. Now for number 2, I could go ahead and square this out and see how it works out. Well, I could just let u equal to x minus 1. So the du would be dx. Derivative of x minus 1 is 1, so it'll be dx or 1 dx. So the du can be replaced by dx. Coming back over here then, transforming the integral into terms of u. Remember, we can't have an x, so the x minus 1, that's going to be u. The dx over here, that's going to be du. Need a replacement for x now. You can always go back to your substitution. I got u is equal to x minus 1. Solving for x, I get x is equal to u plus 1. Here, solving for x, taking the 1 over, minus 1 over, u plus 1. So in the numerator then, I got a 2, and then the x can be replaced by u plus 1. And then the x minus 1, of course, we said that's going to be your u, and then it's squared, so this will be a square here. So we've got everything in terms of u. So let's simplify here. Multiply it by 2 here. It'll give me a 2u, and then I got a u squared here, so that'll be 2 over u. 2u over u squared, 1u cancels out, I get 2 over u. And then I got a plus, 2 times 1 there again is 2. That's over u squared here, 2 over u squared, but I'm going to write that as 2u to the negative 2. So again, I got 2 times u over u squared, reduces to 2u, and then I got 2 times 1 is 2 over u squared, and I write that as 2u to the negative 2. Then I just integrate here with respect to u. 2 over u, of course, that's your ln integral. This will be 2 ln of absolute u. Then here, 2u to the negative 2, add 1, integrate with respect to u, add 1, I get negative 1, divide by that, I get negative 2 here, u to negative 1. All right, so I get 2 natural log of absolute u minus 2 u to the negative 1 plus the constant of integration. And then I just go back to the original variable. So this is 2 ln of u, absolute u, and u is x minus 1. That's your substitution. And I have a minus 2 u to the negative 1. So that'd be x minus 1 to the negative 1. I could live with the negative 1 or bring it to the denominator and say this is over x minus 1. And let me rewrite this. Make it easier to read here. You put the minus 1 out here. And we write it this way, minus 2 over x minus 1. Replacing this u by x minus 1, I can rewrite the final answer in this form. So I get 2, the natural log of absolute x minus 1 minus 2 over x minus 1. And this is your final answer. Thanks for watching. We'll see you next time.